All right, welcome to our second lesson for chapter 10. In this lesson, we're going to continue talking about renewable energies, but we're going to focus on biomass energy specifically. So learning objective is that you'll be able to describe the different sources of biomass energy, as well as the processes involved in their production and refining. All right, so biomass conversion. So all biomass is produced by green plants that convert sunlight into plant material through photosynthesis. Almost all energy that we use, even from fossil fuels, all of that energy originated from photosynthesis. But for this one, we're specifically talking about biomass, so living mass. Biomass fulfilled almost all of humankind's energy needs prior to the Industrial Revolution, where we started using coal. And biomass is still the predominant form of energy used by people in less developed countries. So there are several sources of biomass energy. There's fuel wood. There's municipal and industrial waste. So municipal is like city waste. And then there is also agricultural crop residues and animal wastes. And then finally, energy plantations. So let's start with fuel wood, because it's probably what we're the most familiar with. So in less developed countries, fuel wood has been a major source for centuries. Fuel wood is the primary energy source for about 30% of the world's population. And wood smoke is a significant air pollutant. So as we're in industrialized countries, we're concerned about the pollutants of burning fossil fuels. When we are burning fuel wood, it does not burn cleanly. There's still smoke and soot and pollutants that come off of that. So many people in the developing world use wood as a primary fuel for cooking. Many people cook over open fires. But some places also have efficient stoves that reduce the need for fuel, reduce the time or money needed to obtain wood, and reduce air pollution. So this right here is an open fire. So we can clearly see an open fire under what they're cooking on. But then this right here is an efficient stove. So the flame is within that stove. So it stops things from burning too quickly and helps with heat as well. So waste. Waste can also be burned for energy. Pretty much anything can theoretically be burned for energy. It's just whether or not it's worth it. So waste is a major source of biomass and other burnable materials produced by societies. This is just trash that people have thrown out. This is a dump. And the burning of municipal solid waste to produce energy only makes economic sense when the cost of waste disposal is taken into account. So using municipal solid waste as a source of energy only makes economic sense when landfill costs are high. So in a space like the US, where we have theoretically a lot of land space to throw our things into, it doesn't always make sense for us to burn our waste. But areas like Japan, where they have very, very little space for dumps, but a ton of people and a ton of trash being produced, then sometimes it does make sense for them to burn the waste because they're taking into account that they don't have to pay to store the waste or move it to any new place. They are just moving it somewhere to be burned for energy. But it does not always make sense to burn waste for energy. The next one that was mentioned was crop residue and animal waste. So this includes materials left over after harvesting crop, for example, straw and stalks, that can be used as biomass fuel. Animal dung is another one. So animal dung or waste is dried or burned and then processed in an anaerobic digester to provide a burnable gas. The negative impacts of using crop residue and animal waste are that, one, removing crop residues reduces the supply of organic matter for the soil. We have an entire chapter next semester that will talk about soil, but you really want to leave any living thing or once living thing on the soil for nutrients and also to just protect the soil. So even though we could use this to burn it for energy, that means we're taking it away from its other job. And then two, removing crop residues in the field exposes the soil to erosion. So if you just have an open field of bare soil and wind and rain comes through, then we're going to lose some of that soil, which we don't want. There is such a thing as energy plantation. So many crops, including sugar beets, sugarcane, corn, grains, kelp, and palm oil, can be grown for the express purpose of energy production. So we are growing them to theoretically burn them in some cases. So two factors to determine whether a crop is suitable for energy use. One, good energy crops have a very high yield of dry material per unit of land. So we're going to get a lot of something to burn for how much we're growing. And the amount of energy that can be produced from a biomass crop must be more than the amount of energy required to grow. we put energy into growing crops. So we have to get the seeds, we have to plant the seeds, you have to water the seeds, you have to care for the plants. All of that is energy. So if you're putting that amount of energy in, you need to get more than that amount of energy out. All right, so let's talk about those biomass conversion technologies. So how are we getting energy out of this biomass? So first is direct combustion. We burn it. We light it on fire, we get heat, bam, there's energy. So burning biomass in fires to cook food or heat homes, that is direct combustion. We can also produce biofuels. So fermentation converts plant sugars to ethanol, which is used as an energy source. If you've ever gotten gas or noticed at gas stations, usually it'll say that there's like, it's E10. That means that 10% of that, up to 10% of that gas could be ethanol. And then you can pay more money to have gas that has no ethanol in it. There's also anaerobic digestion. So green wet biomass and animal waste is broken down in anaerobic production by anaerobic bacteria producing methane and CO2. And then there is also pyrolysis, which is a controlled combustion. So we are lighting it on fire. That converts biomass to more useful fuel, such as charcoal, burnable gases, and then burnable liquids. Now, while biomass is a renewable energy, there are negative environmental impacts with almost every source of energy that we're going to talk about. So with biomass, we have habitat and biodiversity loss. So 1.3 billion people cannot obtain wood or must harvest it faster than it grows, which is going to lead to habitat and biodiversity loss. Specifically in Asia and Africa, most of the forest has already been destroyed. And then desertification, which is when the soil kind of dries out and turns into like a desert, has increased in these regions because we're getting rid of the plant life. There's also air pollution. So burning wood does produce air pollution. There's smoke, particulates, carbon monoxide, and hydrocarbons that contribute to ill health. And burning municipal solid waste produces toxic products. So like if you ever go camping or have a fire pit or whatever and you throw your trash into it, you don't want to breathe that air in because you are breathing in all of the toxic particles that was in that plastic or metal. And then we, at the end of this year, end of second semester, we will talk about climate change as a whole. But burning biomass releases carbon dioxide in the short term. And then we need plants living and doing cellular respiration and photosynthesis to remove carbon dioxide to help mitigate the changes caused by climate change. So while they are a renewable energy source, we need them living, not cut down, to help us mitigate climate change and to protect our environment's biodiversity. All right, if you have any questions, please let me know, and I will see you in the next one.